Hi everyone, welcome. I'm glad to be here today because it's also my first time in Switzerland and it's then perfect to be here in Geneva at CERN. And I'm also happy that you're here, that you want to learn something about design patterns. And we will talk about that today. But before we start, I have to ask you a really important question. Who has never been to a supermarket? Okay, good. Because the supermarket plays an important role in this presentation. So it was a bit difficult if you didn't understand the concept of a supermarket. Okay, so I can imagine you're curious how a supermarket, what it has to do with design patterns. But we will get to that in a second. Because first, what are design patterns? Let's get a little bit into what the word actually means. And first of all, it might surprise you a little bit, but design patterns don't give you code. So the design patterns don't give you code that you can copy and paste into your application. You cannot just look it up and then put it in and it works. It gives you more like a concept of a strategy how to solve something, and then you implement it in your own way. And second, they give you general reusable solutions for common problems in software design. And especially the common problems is important because a lot of people think their application is like really unique and so special. No, it's not. A lot of the applications have things that are also found in other applications, but then with different business logic. But because of that, we also have a lot of problems in common. And that's a good thing, because someone else also thought about a way to solve it and how to handle it. And it appears that a lot of the ways to solve a problem work in problems that are similar. So in the end, that's how the design patterns are existing, because we found problems, there are solutions that work in those ways, and they are described and give the patterns. So you can see patterns of the design patterns as a blueprint on how to solve something. So it gives you direction, it gives you guidance, it gives you a strategy to follow, but then you will implement the details yourself. So it will give you an explanation on why a certain direction can work and what the benefits are. And then you take a look at your own application and you implement it in a way that it makes sense and enter a lot more details than you can find in the pattern. So this is in general what the design patterns terms mean. But then still, how did we get to those actual patterns? So we have to look a little bit in the history. And as we talked about before, it's about common problems. So there were 4 guys, and they also have seen a lot of software, and they found there were similar problems and also solutions that worked. So they decided to describe them, and they wrote a book about it. So you might know the Gang of 4, and their book is from 1994. And they described 23 design patterns in it. Don't worry, we won't cover all of them today. And they're divided in 3 categories. So behavioral, structural, and creational. And it's funny because you might think 1994, that's a long time ago. But they're still relevant. So you'll see that some of the patterns are less used today because of a different style of programming, but others are used all the time. And you'll also see that they're combined a lot. It's not one pattern that's the solution for your whole application. Okay, so now we know what they are, how much of them there are. Why would you learn them? So maybe the most obvious one is to gain knowledge. You gain knowledge about how to solve something, how to look at something. Gain more knowledge about architecture and how in different ways you can structure your application. But the funny thing is, sometimes if you will dive into those patterns, you will see patterns where you think like, oh, that's it. It's not that complicated. I'm already using this in my application. I just didn't know it had a name and it was a design pattern. So at least I had that with a lot of the patterns, and also some of the patterns not, they're more complicated and they learn me new stuff. But also if you already knew the pattern, just didn't know it by name, or using it in your application, it adds value to know the name of it, because it gives you a shared vocabulary with other developers. If you have your solution and you want to explain it to someone, you don't have to start at the beginning and explain what you did. You can just say which pattern you use and how you implemented it. So it's just easy if you have a shared way of looking at things. And you might know your own version of the pattern, and now you need to know something more about the details. So before we finally go to that supermarket, I have to introduce you to two people. First of all, this is Bobby. You might know Bobby from Bobby Little Tables. And Bobby also has a friend, Billie. That's weird. So this is Bobby and Billie, and we will follow them today. So first of all, it's a Saturday afternoon, and it's really bad weather. It's rainy, it's cold, it's a perfect day to watch some series. So they're chilling on the couch, and then they hear light footsteps. And then a door opening. And then there's Bobby's little sister. And she's really cute, but also annoying at the same time. She's only 4 years old. And then she throws a note on the table in front of them. And Bobby's like, "What's that?" And she's like, "Yeah, mommy gave it to me." "Okay, but what's on it?" And he says, "I don't know, because she can't read yet, and mom didn't tell her anything." So Billie is the one who gets the notes, and she reads it, and she says, "Okay, it states, Bobby, please do groceries," and then with a list of all the groceries. And they're not really thrilled about this request, because they want to do chilling, but they get up and go to the supermarket. So why did I show you this situation? Because in everything we'll see today, we will find design patterns. So also in this situation, there's a design pattern hidden. So what did we see? First of all, mom wants the groceries. She writes her request on a note that she wants Bobby to do it and what groceries needs to be done. And then she asks her daughter to bring that note to the table. And then Bobby knows what to do with the note. He knows to get the correct groceries. So this is the pattern we saw in the situation, and we also see it in the software design. So it's called the command pattern. And the most important thing of the command pattern is that it encapsulates the request in a standalone object. So in this case, the request was mom wanting the groceries. And instead of going to Bobby directly and tells him it, all the information is on that note. So you can see the note as the command object that contains all the information about her request. And this decouples the trigger from the content of the request. So instead of mom knowing the content and also has to go to Bobby to ask it, she writes it on the note, and then anyone with that note can, without knowing the content of it, make sure it's handled by Bobby. So then the little sister, we call her the invoker in the pattern, is the one who in the end will trigger the request. But because of this decoupling, you are more flexible when you go to choose how to handle it. So as we said, the invoker, which is little sister, doesn't need to know the content. She just has to make sure it's executed. That's just her job. Let's make it a bit more visual. As you see here, I've combined the names of the situation with the names of the pattern. And in this situation, we can see the mom as the client. So it starts with mom, and she knows she wants something done. So instead of going directly to Bobby, the receiver, the one who has to execute eventually what's asked by the client, she creates a note. And that note she creates is a do groceries note. So it's a concrete one which has the execute method and all the details. But then it implements an interface, the node. And the good thing is that the sister only needs to know it's a node. She doesn't need to know it's about groceries. She just knows it's a node. So mom says to her daughter, here you have the node. And then the daughter knows, okay, if I get a note from mom, I have to put it on the table. So that's a bit how the flow works. And then in this case, she knows that every node has an execute. So in the story, we made it that she has to put it on the table. But in the code, she'll have an execute. And she just needs to know that that method is present. And in the execute here, it will eventually go to Bobby. So let's look at that in the code. This code, before you're going to complain, is not going to work. We don't have constructors, stuff like that. It's just to give you an idea, see it as like pseudocode. So on the right, this is the information about the node. So you'll see the interface, which has just an execute method. And the do groceries node, the implementation. And then that node actually knows about the receiver. So it knows Bobby's the receiver and it has the details of the list. So mom is the one who knows the most, of course, because she is the client and she wants this request to be done. So she knows that Bobby is the receiver and she knows which groceries to be done. So that's how she can create that request. And then she will say in the end, invoker set command. So we'll just say to the invoker, here you have this command. And then easy for little sister. She just has to execute on it. That's it. And what we see in here is that the little sister will execute it directly. So as soon as she's called with here's a node, she will bring the node to the table. But it doesn't have to be like that. So because of the decoupling, you can also choose to have a queue or something else. You make sure that the client just knows that it will be executed, but she's not going to worry about everything. So that's what I said is specific for your application. So the pattern gives you the concept of the decoupling, the encapsulation of the object, and then you can choose how to implement it, what makes sense for your application. And then Bobby has to do the groceries. So 10 minutes later, they're at the supermarket. So they first go to the vegetable department, then they go to the cheese department, and then in the end, they go to the coffee, but they cannot find it. Panic, no one can live without coffee. So they're not the only customer looking for the coffee. There are a lot of people gathered around the empty shelf. And then they see an employee. So they ask him, like, where's the coffee? When will it be back? This employee is really grumpy because all day he's been answering questions about the coffee. And the thing is, he doesn't know. So he doesn't know when it's back in stock. He just knows, yeah, it's not there. I don't know when it will be back. And he's really tired of all the questions about when the coffee will be back in stock. So he decided to create a list. He creates a list and asks the customers to write down their details, and he will send them a message as soon as the product is back in stock. So Bobby and Billie write down their information and continue shopping. So what we see here is they ask the employee when the coffee is back in stock, but the employee doesn't know. And he also so tired of everyone asking him all the time, so he decides to create that list and tells the customer that he will update them when it's back in stock. And in a design pattern, we called it the observer pattern. So what you see is there's a one-to-many relationship. There's one object that people are interested, and then there are a lot of customers that are interested in it. And they're all interested in the state of that object. And in this pattern, the key is that the persons that are interested in, or the object they're interested in, they will be notified. So instead of asking all the time, is there something changed? Does something change? Does something change? They will be notified as soon as it is. And in this way, you have really loose coupling. So as long as you work with the interfaces, they don't need to know from each other how everything is implemented, what the objects will do as soon as the product is back. They just know from each other, okay, there will be a notification. So in a scheme, it will look like that. On the left, we have the stock update. So this is the subject that has a state that the others are interested in. And on the right, we have Bobby and other customers, and they're all observers. So all the observers want to know when the state changes. But before they can be notified, they have to register themselves. They have to let that subject know that they're interested in the state. So first, they'll send a request and say, okay, I'm interested. So that's what they'll all do. And then next, there's a request coming in or information to the stock update. Hey, the coffee is back. And at that moment, the stock will just send a message to all the observers. And that's easy for the update mechanism, because it doesn't need to know anything about all the different customers, except that they're observers. And because they're observers, they have the update method. So it just call all the observers that have registered and say, hey, here's the update, it's back in stock. So in the code, it will look like this. On the right, you see you have the observer with the update, and all the customers can implement it. And they can do that on their own way. Maybe one customer goes to the supermarket directly, the other one writes it back on their list of shopping items. That's on their own, but they just have to follow the interface. And then off the left, you see you have register, and there's a list of observers. So when they're interested, they just call the register, and they are just added to the list. And one that we didn't discuss before, there's also a remove method, which makes sense, because if you already bought the coffee, you don't want to be notified again when it's back in stock. Or maybe you already went to a different supermarket and you're not interested anymore. So in that way, you can be removed from the list and not be notified anymore. And then the last one was that notify method, where you see it's just easy as going over the list, find all the observers and send them an update. So also here you see that the pattern in itself is really simple, not so much of code, and you will decide for yourself how exactly you want to use it. Like for example, this pattern is just the key about don't call us, we call you. So they go back shopping, and then the next product is again a challenge. So Billie sees this delicious chocolate chip cookies, but she's a vegan, and she wants to know if she eats those products. So they grab the product and she looks at the ingredient list, and then it's all in Spanish. And Billie is an American, she cannot read Spanish, just English, so she's panicking, like what to do now. But then she reminds herself, it's 2023, I have a smartphone with a translator app. And she holds it in front of the product, and she uses the live function, and she directly sees all the ingredients in English. And she's so happy because the product is vegan, so she takes the cookies. So what we saw is Billie wants to read the ingredients, but they're in Spanish, and she can't read that. Then she uses the translation app, which converts it to English, and she can read English, so now she can see what the ingredients are. And this pattern is called the adapter. And in the adapter, the key is that you have two interfaces that won't work together, they're incompatible, and the adapter solves that. So it converts the interface that some service offers to one that the clients expect. So in this case, let's see, the service has the cookies, their interface is in Spanish, but the clients expect English. So the adapter makes sure that that works together. And this is one use case of it, how we saw it. But there's also a possibility that you want the interface more generic. For example, you're using a framework in your code. Then it might be that if you're implementing or using it, that the code or the way that the framework works is all over your application. And then you want to use a different framework or a different library. And then it's a lot of work to change all your code. So it can be helpful to put an adapter in between that makes the interface way more generic. Just says the basic functionality you need instead of how it actually works in that framework. So that's also a way how you can use it. So here we see it in the scheme. Billie is the client in this case. She needs the service, the product, in Spanish. And she expects it in English. So we create a client interface, says product and get ingredients. So what you need to do for the adapter is to implement that interface, because you have to make sure that you have what the client expects. But then in this part, make the conversion to what the service gives you. So in the code, we'll see that we have a product and a product translator. And that translator implements product. And the product says just get ingredients. And in the adapter, so the product translator, there you have to solve going from Spanish to English. So there you have to do some translation to give it back in English. And then Billie just calls product get ingredients. So what we see here, that in the example I gave you in the supermarket, Billie of course knew she was using an adapter because she knew she held her phone in front of that cookie pack. But that doesn't have to be like that. So as you see here is Billie in the code has no clue there's actually a different product. She just calls get ingredients on the interface. She gets the ingredients in Spanish, and yeah, she doesn't care there's maybe something else behind it. So that's something that will be different in your code or can be different. So next on the list and last on the list is bread. So they first go to the bakery inside the supermarket and they order bread. So they go to the counter, they say, please can I have a bread? And they get sliced whole grain bread. So they get it and it's okay-ish. So the bread is fine, but it's not that crispy. It's fine for just grilled sandwiches or so. But it's Saturday and I want like really nice bread. So Billie has an idea. They go outside the supermarket and they go to the French bakery next to it. And they go inside and they go to the counter and they order bread. But this time they get the baguette. And it's so crispy and it's so nice and it smells really good. So what we see here is they go to the supermarket bakery and order bread. Then they go to the French bakery and they order bread. But they get a different result. They get a different variant of bread. So depending on the location, they get a different bread, but they still get bread. So that's what we call the factory method. What you see here is that in the interface, you define a method for the creation of the product. So there you say, okay, this kind of product needs to be created. And then in the subclasses, you do the actual creation and you can alter the type. So you can give back a subtype of the interface. And this way it's also easy extend, because it's defined in the interface and you can always add new classes that give different subclasses back. So as we see here on the right, you have the bread interface with the two different breads, the whole grain sliced bread and the baguette. And then we have a bakery. And inside that bakery, which is an abstract class in this case, we have create bread. And that's actually our factory method. That's the method that says, okay, I need the bread to be created. And then we have the different bakeries. And they have to actually implement the method create bread. So they have to actually create the objects, but they can change it as long as it's from the interface bread. So in there we'll make sure that they give back the right subtype of it. So in the code on the right we'll see we have the interface bread, and in this case just easy, we have the bake method, and the two different breads have their own way of implementing that. Then we have the bakery, which has to create bread, the factory method, and then if it creates it, the different supermarkets are the ones that actually give you back the product. They will create the object from a different type. So, but now they have smelled that delicious bread, and it made them so hungry. So they're looking at each other and they're doubting, and then they say, yeah, let's go for some sandwich. We're really hungry and we deserved it. So they order the sandwich, and Bobby wants the chicken sandwich and Billie wants the vegetable sandwich. And they order it and the baker starts. So they have different sandwiches with different ingredients, but the baker seems to follow a process. So the baker cuts the bread, put first layer, different ingredients, but first layer, second layer. The chicken one also has a sauce as a topping, and then it wraps it and gives it back to the customer. And then Bobby and Billie have two delicious sandwiches to enjoy. So what we saw is they ordered two different sandwiches, and the sandwiches also have different ingredients. But still the baker follows steps. There's some process that seems to be the same. And there are also steps that are optional. For example, the topping, the sauce is only present for the chicken sandwich. This is the template method. So what we'll see here is that there's some kind of steps and process that's defined in the interface. So in the superclass, you define like the skeleton, things that have to happen. And then the subclasses, they can actually implement it, so they can define how the steps will actually look like. And the superclass can also contain an implementation. For example, if there are steps that are the same for all the subclasses. So as we see here, the sandwich has the prepare method. And this is called the template method. So in this prepare method, there you define what the steps are for preparing a sandwich. And then those different steps, I've now created some methods for it. They can be overridden by subclasses if needed. So, for example, at first layer, that's a method that we need to implement in the subclasses because it differs per step. So the chicken sandwich and the vegetable sandwich both have that method. So see here in the code that on left we have prepare. So prepare has all those steps. This is everything needs to be done for creating a sandwich. So first is prepare the bread. Oh, it's directly here because preparing the bread is the same. So in this pattern you will see that you will follow that things that are the same, put them as high as possible. So in a superclass, because you don't want to copy them in every subclass. And things that differ, put them lower in the subclass. So this is something that's the same, so put it in the superclass. Then we have the first and second layer. There they have different ingredients. So we have to put them in the subclasses. So at first layer of chicken is lettuce, and the vegetable sandwich have the different first layer. So we have to have the implementation for both. But then we get to the topping. And we said from the topping, oh, that's only for the chicken sandwich. So we cannot do the implementation in the superclass because it has to differ. But do we have to do the implementation then in every subclass? Only because the chicken has a topping. That's also a bit annoying. So the solution for that is creating a default implementation in the superclass, which just does nothing. So in this case, there's no topping, but you just define it in the superclass, so not every subclass has to implement it. Then the chicken one, they override it and they add the sauce. But your vegetable sandwich doesn't have the method because they don't need a topping. And then last is the wrap, which is again just a method that you can put in the superclass. So, their bellies are full, their bags are full, they're ready to go home and finally have their deserved chilling time. But then they go home, they drops the bag on the floor and mom is like, no, 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 no. Like, please, store all the groceries first. They roll their eyes, but they know better than to argue with their mom, so they go to work. They put everything what's needed to be cold in the refrigerator. Put the stuff in the cabinets, put it in the pantry. So they do everything on the right place and sometimes even in order. If mom wants the products that are older in front of the newer products. So 5 minutes later, everything is done. They put everything in the right place and they're finally allowed to enjoy their relaxing time. So what did we see? First of all, mom says, put away the groceries. She gives them one instruction. And then Bobby and Billie put everything in the right place, in the right way, but mom didn't give them specific instructions to do that. And she also doesn't know how the steps are taken and which steps are taken. She's just happy with the result. So this is what we call the facade. And the idea of the facade is that you have a simplified interface for the client. So for the client, it's just easy, but there's a whole subsystem. So in this case, the subsystem is all the different places to store the ingredients, the products they bought. And she doesn't need to know about which places there are, how to store it, how to do the filtering of the products. So it removes a lot of complexity for the interface and puts it on a different level. So the complexity is still there, but you just remove it from the client. You will see it like this, that in this case Bobby is our facade. So Bobby is the one who's shielding like the difficult logic for mom. So mom is the client, she just says, Bobby, put away these groceries. Then first of all Bobby knows how to filter the products, how to know which one belongs on what place, and also knows how the items in the subsystem work, if they have specific requirements and how to offer the products, how to put them away. And in this case, maybe it's not really a complex subsystem, but you can see it in different ways. Maybe also, for example, with your home automation, if you have it. You can say, hi, I'm home, and that's it. And maybe then your favorite music will start playing on a certain level. The lights are on, whatever you want at home. So then you see that for you it's easy. You can just say, okay, I'm home, make me comfortable. And then the logic behind it knows what kind of request to make to your lights. What to make to Spotify, all those things. So that's how you can see a subsystem. So this makes it also visually that there's less logic for the client and more behind. So mom is the client, she just knows I can call Bobby and say put away the groceries. And then Bobby has all the logic. So we have even simplified it in here. There's no logic for doing the actually filtering and how to call all the subsystems. But that's everything should be all in the facade. So with this one, we came to the end of all the design patterns we were discussing today. So mind you, this is only 6 of the 23, so if you're interested, you can just read more and more in the books. But first we will look what we found today. So we had the command pattern. It was about all the information about a request, have it on one place in one object, so it can be passed around. So in this case it was a node with the request for the groceries, and that could be given to the brother, to Bobby. Then we had the observer, where everyone wanted the coffee and was constantly asking that at the employee. And because he was so annoyed, he set up a list and said, okay, I will let you know as soon as it's back in stock. Then we have the adapter, which converts two interfaces that are not working together. So Billie can't read Spanish of the product, she expects English. She uses her phone as an adapter in between that converts those interfaces with each other. The factory method was about the different bakeries, where the bakeries have a different kind of variant of bread that they create, and it's their responsibility to create the object. In the factory method, you define that there's a bread to be created. The template method, where we have the sandwiches. And the sandwiches differ from ingredients and the number of layers, but still they have a skeleton in steps of how it will be created. And that's all defined on a higher level, and on the lower level you can do the actual implementation from the steps that differ. The steps that are the same, you put it as high as possible. And last we saw the facade, where mom just had to give one instruction, and then the others can just, or sorry, the others, and then she can just, that's it. And then the subsystem is called by the facade in between. They know how exactly to do that. So one thing we saw with the patterns is that sometimes they're quite limited. So it's just a concept, and it's not about the whole solution. For example, if you think of the factory method, so of the bakeries. So we said, okay, it's the responsibility of the actual bakeries to create that subtype of the bread. So the bakeries know which bread they should give. So that sounds good, like that's the place where it should be decided. But where do you decide which bakery to use? So you'll see that as soon as you start working with them, it's not like a copy-paste solution, because you still have to think, in this case, we let the client decide. So Bobby and Billie, they decided to go into this bakery or go into that bakery. So they decide. But in your code, you still have to create the bakery object somewhere. How are you going to decide which one to use? So you can use another design pattern for that. So you'll see that the patterns are not always big, and you can need multiple design patterns to have a bigger solution. And I don't know for you, but for me it helped to try to design these patterns in a more visual way. So when I started looking into design patterns more and more, every time I Googled them, read a couple like really vague abstract sentences, and then I forgot it the day after. So that's why I try to make a link with a situation in real life, but you can also do it with maybe a piece of code or something else. So if this also helps for you, if you try to learn new stuff or new design patterns, try to make a connection with something existing or something in the real world, or code if that's better working for you, but not just read something really abstract, because it's then difficult to remember them. So I encourage you, like if you go to the supermarket, try if you can find more design patterns, like catch them all or something, and then yeah, hopefully you will be mad at me for going to the supermarket one big design pattern activity instead of just doing groceries. So thank you for being here. You can find the slides if you want with the code, and this is my contact information, but you can also ask me questions now or later. Someone a question? Okay, if it's too scary, you can also come on later and enjoy the rest of the conference.